Okay, so now we're getting to a situation where to see if there's a binomial experiment or a Bernoulli trial, as you talk about in the textbook. And so the things to ask yourself whether or not you can use this technique is, well, first off, are there a fixed number of trials? Do they specify, yeah, we're only going to run so many of these, and for this problem, there's 11 of them, so that's checked. Then the next one is each trial independent from one trial to the next. So does one plant not growing well have any effect on the next plant growing well? Well, we really don't know from this problem. However, they are telling us that from trial to trial, there's a 75% chance that a seed will grow into a healthy plant. So I'm think it's a safe bet to say that these are independent trials and that the probability stays the same from trial to trial, which is the third element. And then there's only can be two outcomes. So did the plant grow or did it not grow? So that's the fourth thing. We can use a binomial distribution. Now you can certainly use all the formulas in the book with the permutations and combinations, and all the probabilities. But I mean, this is about using technology, and so I don't think we need to do that. I'm not going to require you to do that. So your calculator, the book shows you how to use a TI-80 calculator to do this. This applet here that I've got linked to on my applet link on week 0, it asks what's the probability of success, how many trials, how many successes you're looking for, and then it lists a whole bunch of probabilities, which you aren't going to really use on this problem. We only want this one. We want to know exactly 4 don't grow. Exactly 4 don't grow. Now, the tricky part is you probably have already noticed this problem has a 75% here, and I'm using 0.25 here. Why is that? Well, it's the way they worded this. You see how they said don't grow? So that means we've got to find the complement of 75%, which is 0.25%. Make it a decimal, put in 11, type of 4. Then there's a calculate button down there, which you've got to click every time. It won't automatically do it. And because we're looking for the probability of exactly 4, that's the number. And notice that's what my Open Math liked. So I hope I can encourage you to use the calculator. Don't struggle through the formulas. And the really important part is recognizing this is a binomial distribution.